I'm Joe James, and in this video I'm going to explain what is standard deviation, what is a normal distribution, and how do we calculate standard deviation. Now in the previous video we looked at mean, median, and mode as ways of estimating the center of a group of data. In this video we look at standard deviation, which is a measure of the dispersion or the variation of a set of values, or how widely spread out they are. We use the Greek letter sigma to indicate standard deviation, or SD sometimes, or sometimes also just a lowercase s. So a low sigma, or a low standard deviation, indicates that the data are tightly clustered around the mean. And a high standard deviation means that the data is widely spread out. So a normal distribution is also sometimes called a bell-shaped curve. It looks like this. In a normal distribution, the mean, the median, and the mode are all equal to the center value. So if we have a normal distribution, if we look at the mean minus 1 standard deviation, we find about 34.1% of the instances of the data set in this set. And the mean plus 1 standard deviation, we also find another 34.1% of the data set in this range. So plus or minus 1 standard deviation from the mean usually covers about 68.3% of the data. Plus or minus 2 standard deviations from the mean usually includes about 95.4% of the data if it's in a normal distribution. This is only for normal distribution. And plus or minus 3 standard deviations from the mean includes 99.7% of the data. So how do we calculate standard deviation? Let's start with this set of 6 values and try and calculate the standard deviation for those 6. First, we need to know what the mean is. We're going to calculate the mean, or the average, as the sum divided by the count. In this case, we can see that the count is 6. There are 6 values. The sum is just the sum of all these values. So 73 plus 73 plus 76, so on. That gives us 480 over 6, or a mean of 80. So we're going to use this mean in our formula to calculate the standard deviation. So we calculate the mean first. Standard deviation is equal to the square root of the sum, the sigma means sum, of x minus x bar squared over n. So let me explain what each of these is. This sigma is an uppercase Greek sigma, and that means summation. So it's the summation of x, which is each instance of our data, minus x bar or x naught, which is the mean. So the difference between each value and the mean, in this case 73 minus 80 is 7, and then we square that. X bar is the mean, or the average. It's also sometimes called x naught. And n is the count, or the number of numbers. In our case this is 6. Another way we can spread this out, we can take the sigma out and we can say x1, which is 73, minus the average squared, plus x2, which is also 73, minus the average squared, plus etc. for each one of these numbers in our data set, divided by n, the number of data, 6 in our case. We've expanded the formula by removing the sigma. Now if we plug in actual values, 73 minus 80, quantity squared, plus 73 minus 80, again we have two 73s, so we see a repeat there. 76 minus 80, quantity squared, plus 77 minus 80. So you see each one of these values as the first number, and 80, which is our mean, as the second number. So we're taking the difference of each value in our data set from the mean, and then we're squaring that. We're adding all those together, which is the sigma. And then we're dividing by 6. So we get 524 divided by 6, and then the square root of that, which equals 9.3. So our standard deviation, or sigma, is 9.3 for this data set. Now this is not a normal distribution. This is not a bell-shaped curve, not by any means. So when we plot our data on a number line, these are our values, and our mean is 80. So we can see this is really not a normal distribution. It doesn't look anything at all like a bell-shaped curve. We have one guy way up here at 100, and most people are clustered in the high 70s. So mean plus 1 standard deviation is 80 plus 9.3, or 89.3. This is 1 standard deviation above the mean. 1 standard deviation below the mean gives us 70.7. So this is the mean of 80 plus and minus 1 standard deviation, which includes almost all the values in our case, except for the 100, which is about 2 standard deviations above the mean. So that concludes my video on standard deviation. I hope this was helpful for you. If so, please click the like and subscribe buttons. I'm Joe James. Thanks for watching.